Alright guys, we're going to look at another set of examples for solving radical equations. These equations are a little more advanced, there's a little more to them than the previous video. Our goal is still the same. We want to solve for x or k or b, whatever the variable is, but to do that I need to make sure that I first get the radical by itself. So in example 1, I have the square root of x minus 8 equals negative 7. So what I need to do is move the negative 8 away by adding it to both sides. I have the square root of x divided by 8 is equal to 1. And to get rid of the radical, I would square both sides of the equation. The exponent and the radical are going to cancel each other out, and I'm going to keep what's inside. That's x divided by 8, and it equals 1. To solve, I would multiply both sides by 8. And I have x equals 8. Remember, we always want to check to make sure that we're right. So I'm just going to rewrite this. And I'm going to plug 8 in. So the square root of 8 divided by 8 divided by 8 is 1, so I have the square root of 1 minus 8 equals negative 7. The square root of 1 is 1, so 1 minus 8 should equal negative 7, and in fact it does. Negative 7 equals negative 7. So I'm good to go, and that means x equals 8 is the correct answer. Just going to separate this out. Okay, so in example 2, the square root of 2x minus 7 equals the square root of x. Now, notice this is different. We have a square root or a radical on both sides of the equal sign. So I can't isolate it. I can't move them both to one side. All I can do here is get rid of the radical by squaring both sides. So I'm going to take both radicals and square them. So on the left side, when I square the square root, it cancels out and I keep what's inside, which is 2x minus 7. Same thing on the right, when I square the radical, square the square root, they cancel out and I keep what's inside. So I have 2x minus 7 equals x, and to solve, all I'm going to do is subtract x from both sides. I have x minus 7 equals 0. Then I'm going to add 7 to both sides. X equals positive 7. Again, I want to check to make sure that I'm right. So I'm going to plug in my answer, which I'm saying is 7. So I'm going to simplify what's inside the radical first. I have the square root of 14 minus 7 equals the square root of 7. 14 minus 7 is 7, so the square root of 7 should equal the square root of 7. And what do you know? It does. So that means my answer was correct. All right, example 3, same thing. I have 2 square roots. So to get rid of the radicals, I'm just going to square both sides. The square root cancels out with the exponent. I keep what's inside. The square root cancels with the exponent. I keep what's inside. So I have 2k minus 12 is equal to 9 minus k. I'm going to move the k over by adding it to both sides. I have 3k minus 12 is equal to 9. And then what I'm going to do is add 12 to both sides. so that I have 3k equals 21. I'm going to divide both sides by 3, and I get k equals 7. Before I commit to anything, I am going to check. So I have the square root of 2 times 7 minus 12 should be equal to the square root of 9 minus 7. All right, 2 times 7 is 14, so I have 14 minus 12 on the left, and I have the square root of 9 minus 7, which is going to be 2. On the left, 14 minus 12 is 2, so I have the square root of 2 equals the square root of 2. My sides match. I'm good to go. K equals 7 is my answer.